Good afternoon, everybody. So I don't have any, it's basically funded by institutions, so no disclosure. As you all probably know, that patients with interstitial cystitis have increased sensitivity to blood distension and the ice water test if compared to healthy subjects. However, it's still not clear which type of bladder afferents are major contributors to bladder hypersensitivity in interstitial cystitis. So what we did in this preliminary study, we used Zymosan, which is a ligand found in on the surface cell wall of yeast, which activate selectively toll-like 2 receptor and induce poor inflammation. And it's actually very mild inflammation, and we did this in guinea pig. And this inflammation is microscopically similar to patients with non-ulcerative interstitial cystitis. So the aim of the study was, first of all, to validate our animal models of non-ulcerative interstitial cystitis. And the second, we tried to determine which type of afferents were most affected in this model. So the technique we used, before we treat animals with Zymosan, we actually pre-treat them with protamine sulfate for 1 hour. And then we treat with, then we empty the bladder and treat with Zymosan. We found that it's, in this case, it's, we have more consistent result. So we determined the micturition parameters both in conscious and urethane anesthetized guinea pigs. And we also record visceromotor responses, indicator of pain. And when we distend bladder up to 60 millimeter of mercury and record the EMG from abdominal wall muscle. And then we also did extracellular recording, single union recording from bladder afferent in ex vivo experiments. So this first figure shows that when we did Zymosan challenge, we can see the infiltration of neutrophils, mainly in the lamina propria, and we can determine by H&E staining and also using Hanke-Yates staining. Then we did the conscious cystometry. What we found that compared to control, Zymosan-treated guinea pigs, they have significant reduction in voiding volume and increase in voiding frequency. And also what we found quite interesting, that duration of micturition contraction were also increased compared with the control. Then in anesthetized animals, we did the high potassium chloride challenge during cystometry. And what we found that in Zymosan-treated animals, there was significant reduction in decrease in intermicturition interval, while in control was there was small but not significant reduction. When we did the visceromotor experiments, what we found that Zymosan-induced animals have significant hyperalgesia. So the response to the distension was significantly higher in Zymosan-treated compared with control. And finally, when we did recordings from afferents, what we found, and this is preliminary data, so numbers are quite small, that low threshold afferents were not affected by this challenge, while the high threshold afferents were actually sensitized and quite significantly. So what we conclude that our data demonstrate that this Zymosan-induced cystitis in guinea pigs evoked consistent hyperreflexia, hyperalgesia, and enhanced sensitivity to hypertonic calci-L. All this similar to patients with interstitial cystitis. And our preliminary data indicate that sensitization of high threshold bladder afferents could be responsible for hypersensitivity in Zymosan-induced cystitis. And what we're going to do in the future, we want to establish what there was actually ionic mechanism of that sensitization of high threshold afferents. Thank you.
Any questions, please? Can I just ask then, in the meantime, what was the concentration of potassium? Because you said you just put a bolus of half molar.
Yeah, the concentration was 0.5 molar actually.
But how much was it when it was diluted in the urine?
How much when it's diluted? We actually kept that concentration. It's quite high concentration of so we want to see if there is an effect, because in humans, similar concentration used 200, 300 millimolar for determining if there is any permeability change in the urothelium.
Okay, thank you.
Yeah.
And let me ask another one, if I
Okay,
may.
okay.
So, the two threshold, the two populations of nerve fibers, what else do they sensitize to specifically?
Okay.
How do you differentiate between the two?
So, first of all, how to differentiate them? So the low threshold responds to the very low stretch. Some of them will be responding to the fine mucosal stroking, that's so-called urothelial muscular afferents. And the high threshold one, they need higher threshold distension, quite significantly higher. And they will be not responding to mucosal stroking, but they can be evoked by stiff one-fray hair, so we can find the hot spots where the actually receptors is sitting. So,
one C fiber and one A delta fiber?
Kind of. It depends where you measuring. If you measuring within the bladder, what is actually happening, that the A delta fibers probably losing the myelin when they enter in the bladder. And if you're measuring quite close to the bladder, then even this low threshold looks like C fibers, but they're most likely A delta fibers when they go towards the dorsal root ganglion.
Okay, thanks. Okay, well, we ought to stop. Thank you very much.
It's okay.
Thank you.
Yeah.